Hi all, my name is Gulshan Banu, working as an assistant professor, AI and DS department, SNS institutions. So today I am here to present you a topic that is nothing but VC dimensions from the same unit of Unit-2, DEEP networks. So what is this VC dimension? VC dimension, the name of VC dimension has actually been evolved from the name of Vladimir Vapnik and Alexei in 1970s. So they too actually has brought the fundamental concepts in a very statistical manner. Okay, so this VC dimension, it has a mathematical or a representation called as an hypothesis set of H. Nothing but it is the larger number of points that can be shattered, okay, in and around. Okay, those shattered set of points will be represented by the letter called S. Okay, if possible it will be labeled as the S. Okay, there in this hypothesis you will be having different kinds of points that is associated with it, and it will be shattered here and there, and it will be represented as yes. Clear? Now see, in this it is denoted that there are different kinds of points and you have a line. Okay, so what is this point and what is this line? It is all about the different kinds of datas. Okay, those datas are labeled with the points. Okay, and that points are represented by using the value called as the S. Okay, if there are two data points, it will be squared with the value of 2. It will be powered with the value of 2, and in this you have 4 different classifiers. Okay, say for example, if you square this value as 2 square, it will be having 4 different values, and you will be given 4 different kinds of those plotting axes. Okay, so in this you have different datas, and those plotting axes will be different, and the line which intercepts is the actual prediction line that is associated with this VC dimension. Okay, so in this you can have only the maximum dimension of 3, and you cannot have more than 3. Okay, so if possible, if you have any kind of 4 data sets, when you square those with 2, it will be 2 to the power of 4 will be 16, and it will be definitely difficult for different kinds of accessing processes. Now see, this is how the axis alignment will be in a rectangle. See, in this it has a rectangular shape. Okay, so those rectangular shape will be associated with the different plotting values. See, in this you have a value. Okay, based on the previous example, those 4 plots. Okay, those 4 plots were having different kinds of dots, and those 4 plots were aligned together. Correct? So based on those alignment of those datas, you will have those boxes that is associated with it. Okay, ma. So based on this, the boxes will be there. So see, in the first thing you have 2 dots, and those 2 dots is aligned in one box. The green thing is associated with one box. The red is the false value or the unwanted data. So it takes only the wanted value that is associated. So in this, the 4 boxes are aligned. So you have different applications that is associated with this VC dimension. For example, it is used to analyze the complexity of different kinds of neural networks. Okay, where this complexity in neural networks will be used is in the vector mission and the decision trees. Okay, this VC dimension can also be used to design some of the new learning algorithms. It can be robust, or it can be generalized for different kinds of unseen data. The VC dimensions can be extended to more complex learning scenarios such as multi-class classifications and regressions. So these are the different kinds of process that is associated with the VC dimension. So you will have different kinds of hypothesis axis, and the points, those will be plotted. Based on those plottings, you will be having a rectangular aligned axis. So this is very simple concept, and I hope that you understood this concept in an efficient way. So in the next video I will be meeting you with some other different topic. As of now, thank you. Have a good day.